Graphing quadratics. Now we kind of got some fill in the blank here. So, what we're going to do is up here at the top, we're just going to go over some basics of our graphs again. So when it comes time to do it on the test, it's going to be no biggie at all. When we're having a standard form of quadratic functions, sounds so complex, it just basically means, and we've talked a lot about the needs to use our A and B values when we're trying to find a vertex, and we'll get into that in a little bit. But our standard form just lets us know that A is always the number in front of x squared, and B is the number that's going to be in front of x. Anybody remember which one of those words is what we use the name for the shape of our quadratic? Parabola. The parabola. Okay, fancy name for our U shape that we're going to be doing. Kind of keep eliminating things here. Okay, let's start with the easier one. I'm going to go down to 4. I'll come back to 3. So 4, what's that point right there called? The vertex. Nicely played. The vertex is the place where our graph changes direction. So like here it's coming down, down, and it hits that point and it starts going back up. That also might be called a minimum in this case because it's at the bottom of my graph. What's this line that splits it right down the middle called?
Axis of Symmetry.
Nice. The axis of symmetry. And it's called that because if I were to take my paper and fold it along that dotted line, I'd see the exact same parts on both sides. It's symmetrical. So that's why that's called our axis of symmetry. Okay, so we got that one. We're getting there. So when the vertex is at the high point, so in this case it would look something like that. Would this point up here be a maximum or a minimum? Maximum, because it's at the very top. It's the max value that I could have. So that's going to be a maximum. Well, that kind of makes the next question kind of easy. Next one's got to be the minimum. And again, it's going to be a place where the smallest value happens to be. Oops. There we go. Now, solutions, and that's something I didn't get to talk as much about yesterday as I would like to have. Solutions, they have a lot of names for these, and I'm not quite sure why they use all these names. Mr. Osborne and I were talking about this morning, why they use 3 names for the same thing. Our solutions can be called zeros. They can be called roots. And they can, this isn't even on the list, be called x-intercepts. No, x-intercepts went on the next line. I just used it up there. Well, I'll use it in both places. But those words are all interchangeable. So if you're asked to find the x-intercepts, you're being asked to find the solutions, the roots, the zeros. They're all the same term, just for the exact same word. Again, not sure why you want to do it that way. But yesterday we started to talk a little more about finding those roots or zeros or intercepts. And so we take a peek and we say, okay, determine whether the quadratic function has 2 roots, 1 root, or no roots. And if possible, list the zeros. So here's what I need to do. And these don't come through quite as well on the worksheet as I would like. I'm just going to kind of make my axes a little bit darker on all of these so it's a little easier to see. Hopefully it'll stand out a little more for some of you if I am using the red here. You'll be able to tell where everything's at. So now remember, when we're looking for a zero or a root, we're looking to see where it crosses the x-axis at. So how many times does the parabola in number 9 touch the x-axis? Once, right there. So I'd have 1 root, or 1 0. What x value is that at? 3. 0, 1, 2, 3. So my 0 would be at 3, or you could even put x equals 3 to be a little more certain about it. Now be careful. On number 10, how many times does my parabola cross the x-axis? 0. Okay, it crosses an axis, but that's the y-axis. I'm looking to see how many times it would cross x. So this time, I have no real solutions. I have no roots. What about 11? 2. There's one here, and there's one here. So what would my two zeros be? 0 and negative 2. Excellent. And that's where our main focus is going to be today. On either looking at the graph and being able to figure that out, or graphing it and then being able to figure out what the solutions are going to be. Now, we're not going to go through and do every single one of these, but we're going to do several, just again, because I know sometimes we can misplace the notes when it comes time for quizzes and tests and stuff, and I'm hoping this packet can kind of do it all for you. So we'll see how this goes. All right, so number 12, given the graph, identify the following. Okay, you're like, now the axis of symmetry, you're like, how am I supposed to figure that out just by looking at it? Well, there's a couple of things I can do. I notice first, my vertex is right here. What point is that at, my vertex? Because remember, when we're doing the vertex, it's like any coordinate point. We're doing the x value and then the y. 3, negative 2. And the reason I wanted to do that first is that's going to tell me what the axis of symmetry is now. Because the axis of symmetry always goes through the vertex. And it's at that x value, which in this case is 3. Vertex x value, axis of symmetry. Always the same. So if you get one, you get them both. It's a package deal. How many x-intercepts or zeros do we have? 2 of them. And what values are they at? Two and 4. I'm in complete agreement. Okay. I'm not going to worry about domain and range right now. That'd be great if we were going to spend a lot more time in here, but for right now, if we can get that stuff down, I'm a happy camper. Okay, so down here on the bottom, now we actually get to graph again. So we're going to have to do a little work with this. We are going to be using option 2 for these. We have not gotten into the factoring realm of this yet. That's going to come in our last unit. So for now, we're going to find our vertex in the axis of symmetry this way. So I look and I say, okay, first things first, what are my A and B values on number 13? What number's in front of x squared and what number's in front of x? I need to get that cricket sounding app so I can play that at times like this. What number's in front of x squared? 1. Well, she jumps right in. All right. And then my b value is going to be negative 2. And like, okay, so why do I need to do this again? Because I got to figure out where my vertex is, because then I can let the calculator help me, or I can do some other things. So I'm like, okay, there's my formula I'm going to use. So my x value is negative b. So notice I put the negative, and I still kept the negative on my 2 over 2a. What happens when you do negative times negative? Positive. Okay, so the x value of my vertex is 1. To get the y then, all I have to do, and I don't need a fancy calculator for this, but this is the only one I got, so I'm going to use it, is I'm going to take that x value and I'm just going to plug it in for each of these. But I'm always going to use parentheses. Now, if you can do this in your head, hey, I'm all in on this. So all I did basically was plug the 1's in to my equation where the x's are at. And whatever I get out tells me what my y value is. And that's how I get my vertex. So 1, -4 gets me my vertex. And then again, I don't really have to use the calculator for the rest because remember, we run that pattern from here. We talked about it yesterday, but we'll talk about it again here. So normally we're going to go over 1, up 1 from each of our spots on here. And I am going to do that because my a value is 1. It hasn't changed anything. And then over 1 and up 3. So 1, up 3. And if I really wanted to keep going, because I got plenty of room here to do it, I could do over 1 and up 5 for each. Because that's a pattern we've talked about over time, continues on every parabola that we graph. So now, this time I've got my picture. I'm not perfect with my symmetry like it would be if I was using the calculator or something else, but we're close. So I've got my vertex ready. So let's go hand in hand with what that has. What's my axis of symmetry if my vertex is at 1, 4 down here? Yes, my axis of symmetry goes through my vertex. So it's at x equals 1. Good. Is my point down here at the bottom a maximum or a minimum? Bottom's going to be a minimum. Okay, we can circle that. I'm not going to do domain and range here. The y-intercept, remember, I can do one of two things. This time I see it. It's right here. My y-intercept is at 0, -3. Well, what if I didn't see it? You know, is there a way that I could get that if it wasn't quite that easy or quite that obvious? And the answer is yes. Here's what I would do if that happened to me and I didn't get one that I, got a good grip on. I can go to the calculator. There are some things that the calculator can be helpful with. And if I'm looking for my y-intercept, if I get it graphed and just hit the trace button, there's my y-intercept, 0, -3. So it's a nice option to have, okay, if it's not obvious. The calculator can help me out a little bit. Okay, so if I was looking for that again, I would just hit my trace button on the calculator. And then our main event for today, identify the zeros. I see 2 of them. Where are they at? -1, 3. And I really could have gotten away with just having this first sheet, I guess, because I think this covers basically everything we're looking for. So here's how we're going to apply it now. We're going to apply this on the actual worksheet that you're doing. And again, for those of you that mark on the top which thing it is, which is always a good idea, this guy, I get him down here. Okay, we're all the way up. So we have 12? Yes. Homework check 12, numero dos. And our main goal on this is to get how many roots there are on some of these, how many solutions. So up at the top, it's pretty straightforward because they give you pictures for all of them. So that's not bad. But you're like, well, for instance, if we were doing number 1, how many solutions, how many zeros or x-intercepts do I have? 2. Those guys right there. Okay? You're like, I wish they were all that easy. You're like, but what do I do when I get down to the bottom? Because there's no graphs. Well, there's a couple of things I can do. If I want to, I can actually graph them. I gave you some graphs on the back if you want, or if you'd run out of time or something like that, you could graph them. Or, here's the other thing we're going to do. First thing, we're going to get all of these in standard form. What do you mean in standard form? If these are going to be in standard form, I need to see equals 0. If I don't, I need to fix it. So like here, I need to minus the 2 from each side. So I add that equals 0 on the right. But we always want to keep having that equals 0 on the right. So like here, I got two things I got to move. I got to do the opposite of a positive 4x. I got to do the opposite of a minus 3. I know, it gets kind of squished, doesn't it? And notice I'm not combining any of the terms. I'm just writing them down in degree order, from the greatest to the least. So I do have to be careful that I put these in order, because if I switch the order around, that could change my a, b, and c values. X squared, x always goes in the middle. Those guys cancel out, which is always my goal. And I think the only one else that we got to do that to is 11 here. We got to get that minus 2t to the other side. So I'm going to get you into some calculator play with these. Unless, again, you're more of a fan of cranking them out yourself, in which the back of this sheet would be very helpful. So you're like, okay, if you're going to give me an option of making this easier, shoot, let's make this easy. I'm with you. So while some of you are getting that jotted down, I'm just going to get this first one typed in. So x squared, again, the x button's right next to alpha here, but there's a bunch of other junk on there with it. Minus 5x plus 4. I don't need to get to equals 0, just that other side. And when I graph it, notice the only thing I'm looking for is how many solutions there are. How many times does my graph cross the x-axis? How many times does my parabola cross this axis? 2 times, right there and right there. So all I'm going to do is circle the k. Now, if I wanted to find the answers, and I'm going to do that in a couple of these because it's good practice, I could hit second and graph and hope that I would find zeros. Okay, so if I want the zeros, I'm going to do second and graph to find the zeros. And in this case, my zeros, or my answers, would be at -4 and -1, because that's where the y values equal 0. And I can do that on any of these. Could I have graphed that on my own? Sure, I could have found my vertex and graphed that on my own. But I'm a big fan of using the technology when I can. Let's look at one of the trickier ones. Let's look at like number 11. That looks kind of weird. Now, 11, I got to be careful. See that fraction? I'm always going to put the fraction in parentheses. Make sure nothing bad happens that way. Always got to make sure I typed this in right. 1/3 t squared. Okay, x squared minus 2x plus 3. Okay. Where does it look like it's crossing? How many times do you think it's crossing the x-axis? 1, because I really don't see anything below the x-axis. It makes me think it's 1. So let's see if we can actually find a 0. There it is. And we were correct. There is only 1. It gets really close down there again. My intercept would be at 3. Let me get one more of these here. Let's try 9 out. So you're like, okay, so I can kind of just type this in and kind of be an observer of what's going on. How many times that one look like it's crossing? once. Feeling pretty safe here that it's once, but let's check. There's my 0. Ooh, I don't see any more zeros that way. I don't see any going that way either, so there's my one and only 0 at 1. So again, if you just want to use the calculator and visualize things, you can do this whole sheet that way. If you want to do some graphing stuff, you can do it that way. Tomorrow we'll start working with kind of back to some algebra. We're going to do some equation stuff with solving by square roots. And then we'll be ready for the preview and ready for the test and the end of this unit come Friday. Then we can get to our last unit on factoring, the algebra F word.